Hello everyone. Today we will see a right circular cone. The right circular cone is a surface generated by a straight line which passes through a fixed point and make a constant angle with fixed line through the vertex. Now we see the figure. Here right circular cone is a surface generated by straight line. If we consider here straight line and we move the straight line from the fixed point, then we got the cone. And if we consider the constant line and we move around this, then we got the right circular cone. Here the fixed line is called the axis of curve, the fixed point is called the vertex, and the rotating line or moving line is called the generator line. And here the angle between axis and the generator is the semi-vertical angle or semicircular angle theta. Now, for finding the equation of right circular cone, we want some points. We remember this. For finding this, if we know the 2 points A and B, A point is x1, y1, z1 and B point is x2, y2, z2, be 2 points, then the direction ratios of line AB are x2 minus x1, y2 minus y1, z2 minus z1. And if two lines are there and whose direction ratios are a1 b1 c1 and a2 b2 c2, then theta is the angle between them. Then we find this angle by using cos of theta. Cos of theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. For finding the equation, we want the necessary data. First, we want the coordinate of the vertex, that is a of alpha, beta, gamma. Next is the direction ratios of axis. We consider this is LMN and the semi-vertical angle theta. Now we see how to find the equation of right circular cone. We consider the equation of right circular cone whose vertex is at alpha, beta, gamma and semi-vertical angle theta, and the axis line is x minus alpha upon L equal to y minus beta upon m equal to z minus gamma upon n. We see the figure of right circular cone. Here the axis line which is denoted by x minus alpha upon L equal to y minus beta upon m equal to z minus gamma upon n, where this alpha, beta, gamma denotes the vertex and L, M, N are denotes the direction ratios of the axis. Now for simplification, we consider here P of x, y, z be any point on the generator line. Remember, for finding the equation of right circular cone, we want vertex, semi-vertical angle theta and equation of the axis. If we know all these three things, then we take the next point. We use first point, let P of x, y, z be any point on the generator. Then by using this point P, we find the direction ratios of AB, that is x minus alpha, y minus beta, z minus gamma. We find this, we know the point A and the point P. A is the vertex and P be any point on the line. Then we find by using 2-point form, find the direction ratios of AB, that is x minus alpha, y minus beta, z minus gamma. Here we know the equation of axis line. From this we write the direction ratios of the axis are L, M, N. Now for finding the equation of right circular cone, we find the angle between the line AP and AB. For this we use if we know the direction ratios of two lines, then we find the angle between them by using cos of theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Substitute here value of a1 b1 c1 are L, M, N and a2 b2 c2 are x minus alpha, y minus beta and z minus gamma. Now we see the example how to find the equation of right circular cone. Now for finding this, we want the vertex, angle theta and the axis line. Now if we see the first example, find the equation of right circular cone whose vertex is 1 minus 1 2 and the axis is the line x minus 1 upon 2 equal to y plus 1 upon 1 equal to z minus 2 upon minus 2 and the semi-vertical angle is 45 degree. Now here in the example we given all the things, vertex, axis line and the semi-vertical angle. Here equation of axis, here 1 minus 1 and 2, that is x minus alpha, y minus beta, z minus gamma. This alpha, beta, gamma are 1 minus 1 2 are denotes the vertex and 2 1 minus 2 are denotes the direction ratios of the axis. Now for simplification we draw the figure. Here vertex is point A, 1 minus 1 2, angle is 45 degree and the axis line is the given. Now for simplification, first point, if we know all these three things, then first we take P of xyz be any point on the axis line. Therefore here we take P of xyz be any point on the generator. Next we find the direction ratios of AP by using the 2 points. We know the point A and the point B. Therefore by using this, x minus 1, y plus 1 and z minus 2 are the direction ratios of AP. Next, direction ratios of axis. This is the given in the example. Axis line, the denominator terms are L, M, N are denotes the direction ratios of axis. Therefore here 2 1 minus 2 are the direction ratios of the axis and we given angle is 45 degree. Therefore we use the equation cos of theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square is equal to cos theta. Substitute all the values. Here we got cos of 45 is equal to, here a1 b1 c1 are 2 1 minus 2 and the value of a2 b2 c2 are x minus 1 y plus 1 and z minus 2. Substitute. Now for simplification we put the value of cos 45 is 1 upon root 2 and simplify the RHS side. For simplification we take a cross multiplication, then we take the squaring on both the sides and write the given in the equation form. Write the coefficient of x square, coefficient of y square, coefficient of z square, then we write the terms of xy, xz, yz, then x, y, z and the constant. This gives the required equation of cone. Now similarly the next example, find the equation of right circular cone with vertex at 1 2 minus 3 and semi-vertical angle cos inverse of 1 upon root 3 and line x minus 1 upon 1 equal to y minus 2 upon 2 equal to z plus 3 upon minus 1 as axis of cone. Now similarly we find the equation of right circular cone. Here we given the three things, point that is the vertex, semi-vertical angle and the axis of cone. Now if you know all these things, Then first we take P of xyz be any point on the generator. Here A be the fixed point, which is the vertex, which is 1, 2, minus 3. Now if we take P of xyz be any point on the generator, then we write the direction ratios of the AP. For this we know the point A and the point P. By using this we got the direction ratios x minus 1, y minus 2 and z plus 3. Now in the example we given the direction ratios of AB are 1, 2, minus 1. Now we know the direction ratios of AB and the direction ratios of AP. By using this we find the equation of right circular cone. Here we take cos of theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Here we substitute the value of theta is cos inverse of 1 upon root 3. Value of a1 b1 c1 is 1, 2, minus 1 and a2 b2 c2 are x minus 1, y minus 2, z plus 3. Substitute the values. Now for simplification, cos of cos inverse, here we got only the angle which is value, that is 1 upon root 3, which is equal to the RHS side. Simplify this. For this first we take cross multiplication, then squaring and write the equation form. We got the required equation of right circular cone is x square minus 2y square plus z square plus 4yz minus 2zx minus 4xy plus 12x minus 4y minus 4z minus 36 is equal to 0. It's the required equation of right circular cone. Now we see the next example. In next example, find the equation of right circular cone which passes through the point 1, 1, 2, has its axis the line 6x equal to minus 3y equal to 4z and vertex at origin. Here if we see the example, in this we given the vertex is origin, we given the axis line is 6x equal to minus 3y equal to 4z, and we given the cone passes through the point 1, 1, 2. Here we given only the two things of our origin, that is the vertex and the axis line, but here cannot given the angle theta. Therefore first from our three things we given only two things, angle is not given, therefore first we find the angle and then we find the equation of right circular cone. Now for finding the angle we consider 2 points. If we given the 2 points, then we find the direction ratios of AQ. Here we consider this 1, 1, 2 is the point on the generator 1, 1, 2, and we know the point vertex is 0, 0, 0. By using this we find the direction ratios of AQ and we know the direction ratios of AB. Then by using these two direction ratios we find the angle theta. Now we see how to find this angle theta. Now for this, first we simplified this equation of axis. We given the equation of axis is 6x is equal to minus 3y is equal to 4z. Now here we write first, this is in the standard form. For this we make the coefficient of x, y and z 1, 1, 1. For this we dividing by 6 and then we dividing by 2. If we dividing by 6, then we got x is equal to minus y upon 2 equal to 2z upon 3. Simplify, we got x by 2 equal to y upon minus 4 equal to z by 3. This is the equation of axis where vertex is 0, 0, 0. Therefore here on the numerator we got x, y, z, and on denominator 2 minus 4, 3. This 2 minus 4, 3 denotes the direction ratios of the AB. Here, direction ratios of AB are 2 minus 4, 3. Now, by using 2 points, we find the direction ratios of AQ. A is the point which is the origin, and Q is the point the cone passes through that point, that is 1, 1, 2. Therefore, we got the direction ratios of AQ are 1, 1, 2. Find the angle between this AQ and AB, that is the angle alpha, or we consider theta. Alpha is the semi-vertical angle, therefore cos theta is equal to, we consider A1 A2 plus B1 B2 plus C1 C2 upon root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Now substitute all the values. And find the angle alpha. Here A1 B1 C1 are 2 minus 4 3 and A2 B2 C2 are 1 1 2. Substitute, then we got cos of alpha is 4 upon root of 174. Now we got all the three things. Vertex is the origin, axis is given. We write this is in standard form, x by 2 equal to y upon minus 4 equal to z upon 3, and the angle 4 upon root 174. Now find the equation of right circular cone. For this, take P of xyz be any point on the generator. Then find the direction ratios of AP. We got this is xyz. Here we know the direction ratios of AB, 2 minus 4 3. Therefore we find the cos of alpha, which is equal to A1 A2, that is x into 2 plus B1 B2 y into minus 4 plus C1 C2, that is z into 3, upon A1 square plus B1 square plus C1 square, that is x square plus y square plus z square, into root of A2 square plus B2 square plus C2 square, that is 4 plus 16 plus 9. We substitute the value of cos alpha is 4 upon root of 174 and simplify the RHS side. For simplification, we take squaring. If we square, then we write in equation form. If we write in equation form, then we got the equation of right circular cone, and the given right circular cone